When solving one-step equations, you have to make sure to identify the operation that's happening in the problem and then what inverse operation cancels that problem out. So if we look at example 1, step 1 would be to draw a vertical line down the equal sign in order to help keep our equation balanced. What we do to one side, we also have to do to the other. So step 1 would be to draw the vertical line. Step 2 would be to identify what side the variable is on. Notice my variable, which is letter B, is on the right side of my equation. Once I identify what side my variable is on, I need to see what is happening to that B. Well, that B is being subtracted by 3. So the opposite of subtracting 3, the inverse operation, would be adding 3. Now notice how I'm going to keep organized with my work. I'm writing the plus 3 right underneath, and I'm writing the plus 3 on the other side as well. Notice on my right side, the negative 3 plus 3 cancels out, and I just have my variable, which is B. And negative 7 plus 3, if I don't know that, I plug that into my calculator and I get negative 4. If you look at example 2, after drawing your vertical line, you want to identify that the variable is on the left side of the equation. Since the variable is on the left side of the equation, you have to identify what's happening to it, and this variable is being added by 13. The opposite of adding by 13, or the inverse operation, would be subtracting 13. What you do to one side, you have to do to both. The 13's canceled out. That was my goal, was to eliminate or solve the equation. My variable drops down, and 27 minus 13 is 14. If we look at example 3, you notice my variable is on the left-hand side. The variable is being multiplied by 4, and so the opposite of multiplying by 4 is dividing both sides by 4. Notice how I show it with the division bar. 4 divided by 4 cancels out and gives me 1x. 64 divided by 4 is 16. Once you have your variable by itself and the leading coefficient, or the number in front of that, is a 1, then you have solved your equation. So notice I've solved all 3 of those equations. Looking at example 4, what's my variables on my left-hand side? The variable is being divided by 4, and the opposite of division by 4 is multiplying both sides by 4. The 4's cancel out, and I drop down my x. I bring down my equal sign, and negative 9 times 4 is negative 36. In the last 2 problems, they're a little bit different. So I'm going to draw my vertical line and notice that my variable is on the left side. Now that variable is being multiplied by a fraction, and you can attack this problem one of 2 ways. The opposite of multiplying by a fraction could be dividing by that fraction on both sides, dividing by 4 over 5 on both sides. However, in order to eliminate the fraction, you can also multiply by the reciprocal. The reciprocal of 4 over 5 is 5 over 4. What you do to one side, you must do to the other. My variable drops down. I drop down the equal sign, and 28 times 5 over 4 is 35. My variable is now by itself, and so my equation is solved. Lastly, what you see happening to k is k is on the left-hand side, and k is being added to a negative 17. Your first reaction would be probably that the opposite of addition is subtraction. However, you have to think further than that and say to yourself, if I subtract 17 on both sides, will that eliminate the number with my letter? Well, no. If I do negative 17 minus 17, that does not cancel out and equal 0. And so you have to look at this problem a little bit differently. You have to say, well, what number is with my k? A negative 17. The opposite of a negative 17 is a positive 17. So I'm going to add 17 to both sides. Notice how now I have negative 17 plus 17 cancels out. I drop down my k, I drop down my equal sign, and 3 plus 17 is 20. Now found my variables by itself, and I solved the equation.